I'll just give it one more minute. All right, I think we can go ahead and get started. So, hi everyone, thank you for joining us today. My name is Daria Minovi. I'm a policy analyst at the Center for Progressive Reform, and we're really happy to have everyone on today to talk about the Lower Shore Safe Well Water Initiative and to do a well safety training together. So just to do a little bit of housekeeping before we dive in, if you're having any problems with your audio at all, we've got, you can call in with the phone number. I'm sure everyone's an expert on using Zoom at this point, but we've got, you can call in if you need or chat Maggie, who is the CPR account. You see her image on the chat if you have any issues and need any tech support. We're going to keep everyone muted during the webinar just to reduce background noise. If you've got any questions, you can use the Q&A box at the bottom of your screen, and we'll address those during the question portions of the webinar. And just so everyone's aware, this webinar is being recorded. Several folks weren't able to make it and asked to receive that afterwards, so just be aware of that. And we will share that link after the event. So today we're going to talk about the Lower Shore Safe Well Water Initiative, what this program is, why it came about, and then I'm going to hand it off to Rianna Murray at the University of Maryland School of Public Health to talk about the project findings, what we learned, and then for the bulk of our time, Jean Holloway from CERCAP is going to lead us through a training on private well safety and maintenance, and it's going to be tailored to Marylanders. So we're hoping to wrap everything up by 7:15, and there will be plenty of time for questions as you have them. So for those, I know several folks who've joined today are from the Lower Shore Safe Well Water Initiative, which is great. I've probably emailed with you over the last few months, but I know others came through Sentinels of Eastern Shore Health or other organizations. So for those who aren't aware of this initiative, the Lower Shore Safe Well Water Initiative is a joint project by the Assateague Coastal Trust, Center for Progressive Reform, Environmental Integrity Project, and the University of Maryland School of Public Health. ACT, CPR, and EIP all work on research and advocacy to protect Maryland waterways and drinking water quality. And our partner researcher at the University of Maryland has done extensive research on well water quality in Maryland. So we're all sort of working on these issues in different ways. This investigation into well water in Maryland, and specifically on the Lower Eastern Shore, came about after community advocates, environmental advocates, activists in the region were concerned about nitrate. They'd heard of it, they knew it was a toxic drinking water contaminant that you often find in agricultural areas like the Lower Shore, but they didn't really know whether it was a problem for the region. So one of my colleagues and I at CPR decided to look into this issue, which culminated in a report that we released in October of last year, where we found that about 1 in 25 wells in Maryland, in the Maryland Lower Eastern Shore region, had nitrate levels above 10 milligrams per liter, which is the level at which it's considered hazardous to human health by the EPA. That being said, this standard was set decades ago, and a lot of research has come out showing that lower levels can be hazardous as well. So upon further analysis, we found that something closer to 1 out of every 10 wells in the region may have had hazardous levels of nitrate. And while these results are certainly alarming, because private wells aren't regulated by the federal government and there's no requirement to test them pretty much after they're drilled in Maryland, we didn't really have a sense of what well water quality looks like right now, because the data that we had went all the way back to the 1960s. So it was really a snapshot of what the well looked like at the time it was drilled. Our research also showed that Maryland is one of the states in the country with the fewest protections in place for private well owners. Unlike Maryland, other states have programs that provide free testing kits or low-cost test kits, like Delaware. Your neighbors got $4 well water testing kits. Other states like Iowa have grants to help homeowners clean up contaminated wells. And many other states also have public databases that have well records available, so you can go up and look up information about your well. A poll we conducted in November also showed that most lower shore well owners aren't regularly testing their wells, and we also found that lower income households were less likely to test their wells. So as a result of these various questions and concerns, our organizations banded together to form the Lower Shore Safe Well Water Initiative in the spring of this year to better understand what nitrate levels look like right now and to help provide residents with more information and resources to safeguard their drinking water. So with that, I'm going to hand it off to Dr. Rianna Murray at the University of Maryland School of Public Health to talk more about the program and what we found. Dr. Murray is an assistant research professor at the University of Maryland Institute for Applied Environmental Health. She is the program manager of the Global Stewards Program, an NSF-funded fellowship that prepares doctoral students to be interdisciplinary researchers at the Food, Energy, and Water Nexus. And she is a researcher with the Conserve Center for Excellence, supported by USDA and NIFA, which investigates transformative on-farm treatment solutions that enable the safe use of non-traditional drinking water, or sorry, irrigation water. So with that, I'm going to pass it off to Rianna.
Hi, thank you, Daria, so much for that introduction, and welcome to everyone who is on the call. Thank you for joining us today. As Daria said, my name is Rianna Murray, and I'm an assistant research professor at the University of Maryland School of Public Health. And the photo on the right is of Suhana Chattopadhyay. She is a PhD student who was also really instrumental in getting our project off the ground. So without further ado, I will give you a little bit of update of the project results that we've gotten so far, which was the collaboration that Daria talked about between us and Assateague Coastal Trust, CPR, and the Environmental Integrity Project. Next slide, thank you. So why do we want to test well water? A little bit of background here. So as we know, safe drinking water is fundamental to protecting people's health. And in communities where there's heavy agricultural activity, pollution that's emitted from farms can definitely impact the environment and also public health. So we were mostly interested in nitrates in this study, and nitrates are a colorless, odorless, and tasteless compound that are formed when excess nitrogen from manure, fertilizer, or septic systems break down. And they can get into the soil and also into our water through groundwater. So nitrates are a very important plant nutrient, but in excess amounts, they can actually contaminate the groundwater that we rely on for drinking water and thereby endanger people's health. So most times, people who are on private wells are the ones who we are most concerned about in terms of nitrate exposure. And well water is not, this is because well water is not protected by the federal government. And the state of Maryland also does not regularly test any private wells. We don't have any either federal or state level restrictions or regulations around well testing. So because of that, we decided to do this study in order to sort of assess the level of potential nitrate contaminations of wells in the Lower Eastern Shore region. Next slide. So the goals of this project were to understand the current extent of nitrate contamination in the wells of the Lower Eastern Shore. And everybody on the call today knows where the Lower Eastern Shore is, but the map on the right, we can see those three red counties, Wycomico, Worcester, and Somerset. So to engage, also, we wanted to engage residents in a citizen science project to sample for nitrates in their well water using test strips. So citizen science is where we get the public involved in doing testing or monitoring and so on. So we get the input of the public in science related research that we do. So that's why we call it Citizen Science Project. And we also wanted to raise awareness about public health risks of nitrate pollution in drinking water and to give strategies that well owners can employ to mitigate risks. So that's what we're doing here today with all these great folks on the call. Next slide. So just very briefly, our project methods, we launched an intake survey on April 1st, 2021 this year. So this survey is actually available on our website, and most people who are on the call, you probably were a participant in our study, and you would have gone on the website and completed an initial intake survey. And then you would have received a test kit by mail as long as you fill out your address. And the test kit would have included a brochure, a self-addressed envelope, and test strips for well water testing. And the test strips are basically that second photo there. You see the bottle with the strips on the next to the bottle on the ground. So those are the test strips that we use. And we asked participants to take a sample of their kitchen sink, water that comes from the kitchen faucet, and use the test strips to then determine how much nitrate was present in their water. And we had a video tutorial for this water testing on our website. And then participants were able to either inform us by email, by taking a photo of the brochure that was included in the test kit, or they could have mailed the brochure back to us. And we also offered additional confirmation testing to all participants who had nitrate levels that exceeded the EPA maximum contaminant level. So the EPA is the Environmental Protection Agency, and they are responsible for setting drinking water standards. And they set drinking water standards for both water that comes from public water source, as well as water from wells. And we were able to then compare the results of what folks told us that their nitrate levels were with the maximum contaminant level that the EPA sets out, which is 10 milligrams per liter. So that's how much nitrate should be in your water in order for it to be safe. All right, next slide, please. All right, so one more, thank you. So we had a total of 152 people sign up between April and about 2 weeks ago for the survey, and there were 15 people who signed up from Somerset, 69 people from Mercomaco, and 68 people from Worcester. So we then those folks were able to test their wells with using this strip and send us the results either by mail or email. And based on the 109 results that we received, we got 9 back from Somerset, 48 back from Mercomaco, and 51 from Worcester. Next slide, please. All right, so this is just a brief look at the nitrate levels that we found across all the samples. So across all the samples, we found that the majority of the wells that were tested definitely were below 5 milligrams per liter. So what we did is we sort of broke it apart in terms of the just the level of hazard that we believe. So 10 definitely set out by the EPA to be the maximum contaminant level. So 10 and over is where it's not compliant with the EPA standards. And then less than 5, there's really just not much of any type of health risk there if it's under 5. And then between 5 and 9, there's a potential health risk, but it's not at the level of 10 milligrams per liter just yet. So we see here that most of the wells were under 5 and under. And then we had 14 wells in total that were between 5 to 9 milligrams per liter. And 10 wells were actually 10 milligrams per liter and over. So we had 10 wells in the study out of the 109 that were over the EPA maximum contaminant level. And so any folks that were 5 and over were then offered a follow-up free confirmation testing to take a sample of their water and take it to a lab to have it tested, confirmation testing. And of those people anybody who was over 5 was allowed to do that. And we had 7 people sign up to get their wells, the well water tested at a lab and for nitrate. And out of those 7 folks, we had 3 people whose wells were confirmed to be over 10. And we followed up with those folks to be able to give them sort of information on what they could do next steps. On next slide. All right, and then this is nitrite levels. So we did a test for both nitrate and nitrite. The strip is able to test to give a result for both nitrate and nitrite. And nitrite is just a different form of nitrogen, and nitrogen can exist as both nitrate and nitrite. And nitrate is the much more stable form. So there's nitrite, but there's typically much less nitrite than nitrate in the soil or in your water, actually. And the maximum contaminant level for nitrite is 1 milligram per liter. And we saw that everyone's wells were underneath that 1 milligram per liter cutoff. So we have here folks ranging from 0 to 0.3 in terms of nitrite levels. And next slide. All right, and then this is a great map that Daria created for us to sort of get a visual of where the samples were that were that were below 5, between 5 to 9, and then over 10 milligrams per liter. So the red dots indicate where the samples were located that were 10 and above, 10 milligrams per liter and above of nitrate levels. And then the yellow dots between 5 to 9, and the green dots were less than 5. So we see that there was a sort of a concentration of the yellow and red dots around the Salisbury sort of area there. And then there was one sort of one sample over on more so on the Ocean City, it looks like, area over on that side there. So this is a great visual representation of sort of the spread of our findings. And our next step would be to look to see if there's maybe near any of these results, these wells, if there was CAFOs and other agricultural farms in those areas, that we can maybe sort of take a closer look at that. I think that's our next step. And then I think that is it. Daria, if you can go to the next slide, that is our question slide, I believe. Yes.
Yes, thank you, Rianna.
You're welcome.
So before we launch into questions, I did want to add to Rianna's points that these findings are relatively consistent with what we found in the report that we released last year. But one thing to note is that while this is like a pretty small sample of wells, the proportion of those that fell within that 5 to 9 range was actually higher than what we found in our research. So it's certainly still concerning. As Rianna said, it's not over the EPA's limit, but new research is showing that you can still have adverse health effects with consistent long-term exposure to 5 milligrams per liter or above. Consumption of nitrate, especially because nitrate, you can't take it out of your water with boiling or chemical disinfectant. You need something like a reverse osmosis system to really remove it from your water. So we certainly recommend that folks continue testing their water annually, and Jean's going to give a great training on this later. And with that, I also want to share that if anyone is on the call that is in the Lower Shore region and has a private well, if you want to sign up for this program, you still can. I will put the intake survey link in the chat, but we're still enrolling participants until we run out of test strips. So if you want to participate, definitely sign up. Or if you've participated and want to involve your neighbors in the program, the more data we have, the better, and we'll only go until we run out of test strips. So definitely, this is going to be likely a one-time initiative. So if you're interested, definitely sign up before it's over. So with that, we want to just open it up for any questions that you might have for Rianna, and be sure to put those in the Q&A.
So I see that we do have a question. Were you taking into consideration the well type or construction? So we did ask that on the intake survey, and we have not yet done any statistical analyses to see if that did play a role, well type and construction, because we do know from previous studies that sometimes well type and the way that a well was constructed can actually play a role in nitrate contamination as well as in bacterial contamination. So we haven't done any statistical analyses yet to determine that, but that's sort of like our next step. We just wanted to report right now on the nitrate levels as we have them. And then someone asked, how do we sign up? And there's a link in the chat box to be able to sign up.
Yes.
It's the lowershoresafewells.com. And if you go there, it's pretty, there's a button where you can just hit take our survey and you can sign up that way.
I just put it in the chat and also in the Q&A, but yes, if you are a well owner and you live in Somerset, Wycomico, or Worcester County, even if you rent your property and you have a well, you are welcome to sign up there in the intake survey, and we'll get that test kit to you within the next week or two. All right, any other questions for Rianna or the Lower Shore team before we hand it off to Jean? And there will be opportunity to continue asking questions later at the end if anything comes up. Okay, so if that's it, I want to go ahead and introduce our next speaker, Jean Holloway. For those who don't know Jean, so she is the technical assistance provider for the Southeast Rural Community Assistance Project, or SURCAP, and she specifically works with their Delaware and Eastern Maryland office. She's been with SURCAP since May 2016, has been conducting training for small communities and community utilities since 1996. She's a Delaware licensed water operator and worked previously for the Region 3 Environmental Finance Center, rural water associations in both Maryland and Delaware, and is a town administrator and circuit rider town manager on Maryland's Eastern Shore. So she is an expert on this issue, an expert on this region, and is going to lead us through a great training on well safety and management for the remainder of the webinar. Thanks, Jean.
And thank you, Daria. I'm always a little nervous when people describe me as an expert, because I don't feel very expert sometimes. But at any rate, thank you all for attending, and good to see this many people on the webinar. And for the record, I'm one of those 68 people in Worcester County. Unfortunately, my results are not included in Rianna's statistics because I just remembered to do mine today. But I am a well owner and a Maryland native as well. So this is based on my presentation is based on training that we do throughout our region, and it's developed partly with slides from the private well class with which we're affiliated, and the National Groundwater Association. If my voice breaks up, I'm sorry. I'm getting over a pretty nasty cold. So what I'm going to talk about, obviously, you've had the welcome. I'm going to talk very briefly about SURCAP and who we are and what we do. We find that sometimes people have not heard of us, and we're trying to counteract that as much as we can. And then what you can expect to hear is a little bit about how groundwater works, how it gets recharged, how it moves through the soil, how wells work in particular, and common problems that we see, not just on the lower shore where I live, but throughout our mid-Atlantic region, our southeastern region, and what you can do to protect your family, and the resources and help that we have to offer, not just us, but a number of links that will appear in the slides at the end. Just briefly about SURCAP, we are a 501c3 corporation, nonprofit corporation. And our mission is to improve the quality of life for people living in rural communities. And we serve a 7-state region from Delaware down to Florida. There are 6 such regional organizations that make up the Rural Community Assistance Partnership. We are now in I believe we're now in our 52nd year, if I'm not mistaken. But we advocate for not only private wells, but for community systems, provide technical assistance to community systems and so forth. And our estimate is that we've helped over 450,000 people in our region so far and counting. There's just a brief map to show the different regions, and this, of course, is us over here on the right. Some things that are important to remember is that once installed, and it almost doesn't matter what state you're in, it's not peculiar to Maryland, certainly, but once the well is installed, they're not regulated. They're not regulated as a community system is regulated, as so-called town water is regulated. So it's really up to the property owner to take care of it, to protect themselves and their family. Well water can be the best tasting and the safest water around, but it isn't always, and it isn't automatically the best, safest water either. There's so many things in water that can harm you, nitrates being one that you can't see, taste, or smell. So it could be extremely high and you would never know. That's why it's so important to have your water tested. And people who complain about the taste of a community system water usually are complaining about the smell and the taste of chlorine, but that chlorine is actually what protects them from biological contaminants, bacteria, which you do not have if you have a private well. Again, contaminants can be completely undetectable without a test. These community systems charge an average of $40 to $50 a month. Some places are higher than that, some places are less, but to cover the cost of maintaining that system in compliance and to ensure safe water and to protect the public health. As a well owner, that's entirely your responsibility and your expense. And that's an important point to remember. If you don't already, if you've ever had to replace a well or a pump, you already know it's expensive. Let's talk about where the water comes from. Groundwater comes from either a bedrock well, which we don't see in our region very often. What I see most, and what most of us probably have, depending on the age of our homes, is a sand and gravel aquifer, a well that's in the sand and gravel aquifer. Is there a question? I hear someone speaking. Anyway, there's also shallow soil infiltration. What we would call the water table is a shallow depth. That's not really an aquifer. It's infiltration from the surface into that first layer of soil. If you remember your elementary science, the water cycle, some people tend to forget there is no new water. All the water there is all the water there's ever going to be. And it all is it either comes down in precipitation and either runs off or infiltrates into the soil, into the water table. It may get down into the groundwater depending on how long it's had to seep down into the soil, and then eventually it evaporates and transpirates up into the clouds. And once they get heavy, it's with condensation, then it comes down again. And it's just a cycle that keeps going. There is no new water. And we think of it as an infinite resource, and it is replenishable, but it is not infinite. The types of wells that we see or that are possible are bored, which in Maryland are no longer allowed, drilled, which is the standard operating procedure nowadays for most states. Driven also don't usually occur in Maryland, not as a new well. It may be an existing grandfathered well. And hand dug, which is kind of like the old days with the bucket and the rope and the crank. I don't see too many of those either, unless it's something that's been in existence for many a year, but most of us have a drilled well. The sand and gravel well is actually down into water-bearing soil. Some people make the mistake of thinking that there's some sort of underground channel or underground river. There really isn't. It's saturated soil that the well goes down into. There's a screen, which is usually wrapped with wire. You see an example picture on the right. Well, it's on my right. I hope it's on your right. And the casing is usually PVC or stainless steel or steel, depending on where you are and when the well was constructed. The size or the gap between these wires that constitute the screen depends on how much water you're trying to pump and what the size of the particles in the formation that you're in. So if there was a lot of, say, for instance, gravel, maybe there would be slightly wider slots in the screen. If it was very sandy, very fine, it would be narrower slots. This is a typical cross section of a well. You start up at the top with the well cap. And in Maryland, if a well is 4 inches or larger, a two-piece vented cap is required. If it's less than 4 inches, your well might just have a plastic cap. Looks like a little dome on top of the pipe. This is probably sticking up in your yard somewhere. The discharge line is actually what takes the water into your house or into your house's plumbing. And then next would be the pitless adapter, which allows the pump to operate without being down in a pit, as the name implies, because the pits have their own safety drawbacks. And then the drop pipe is how much pipe is between that pitless adapter and the top of your well screen. Then you have, of course, an electric cable, and a casing is the pipe in which the well shaft and the well pump is located. That's the outside casing that protects sand from getting into your well, provided it's not breached. But that's another part of the presentation. And then, of course, the well screen, the picture that you saw on the previous slide, would be next, and then the submersible pump. This is a rhetorical question, something to think about, but do you know what kind of well you have? What type of well construction you have? More than likely, it depends on the age of your house and the age of your well, how it is constructed, because there have been a number of regulations that have come into play since probably the 1980s that might make a difference if your house is older than, say, 84. My house was constructed in 82. So ours is constructed one way, and one that would be built right next door tomorrow would be constructed differently. They're probably drilled, but it would be of different material. So how does your well get contaminated? Well, water is a universal solvent. Basically, anything that it goes through or that goes through it can be dissolved in the water. So that's why it's so important not to pour stuff out on the ground and things like that. I know my late father-in-law used to pour, I'm talking 40 years ago, used to pour burnt oil on the drive lane to keep the dust down. And when I started learning about water, my first thought was, oh my goodness, that's not a good thing. But anything you pour out on the soil has the potential, at least, to leach down into your groundwater, into the aquifer, and take bacteria from the soil with it. Breaks in the casing, or something that's poured out that runs down the outside of the casing could potentially get in the aquifer. And anytime you have a well, you're actually punching a hole in that aquifer. So if you think about it as if punching a hole in your skin provides an opportunity for bacteria, punching a hole in that aquifer can provide the same opportunity. Your well or your house plumbing could be, if your house is older in particular and has certain types of piping or solder, particularly copper or lead solder. It might not be your water that's bad. It could be your water is aggressive or corrosive, and what's actually leaching into your water could be coming from your plumbing rather than your source water. It just depends on when it was built. And then, of course, pollutants that have entered the groundwater, like nitrates from agricultural and lawn fertilizer and septic breakdown and malfunctioning septic systems. Some of the common contaminants that we see, bacteria, obviously. And I'm going to talk a little bit about the difference between if you get your well tested, a full panel of tests, and it comes back positive for total coliform. That's not something to be too alarmed about, because total coliform is all around us. It's in the soil, it's on our skin, but it is an indicator organism. If you have a positive coliform, indicates you need to have it tested for bacteria like fecal coliform and E. coli. So just because it's positive for total doesn't mean you need to get scared, but it means that you need to run more tests, and most labs already know that and will do it automatically. Nitrates, of course, which was the subject of the study. Nitrates are extremely dangerous in my view, simply because they're tasteless, colorless, and odorless. They can be very high levels and you not know they're there. Our son lives in a farmhouse where my husband was raised, and we had the water tested right before he moved in because he has 2 young children. They were much younger then, but the water tasted great. The water was wonderful, and everybody thought I was crazy because I insisted on testing it. And their nitrates were 21.6 parts per million. So I was very grateful as well as vindicated that we had it tested. Lead is another thing that tends to be very newsworthy, especially after what happened in Flint, Michigan. That can be very dangerous for young children and for pregnant women, but it's not good for anybody, obviously. But the usual source of lead is not the water itself. The usual source of lead is in the plumbing, and the water has a very low pH, meaning it's acidic, and it is corrosive and leaches the lead out of the plumbing or out of the solder. So if you have lead in your water, chances are, it's not impossible, but chances are it's not coming from your water itself, it's coming from the plumbing. Arsenic, just that word scares people, but arsenic occurs naturally in groundwater at fairly low levels. You only need to be concerned when it gets above a certain maximum contaminant level. And there are other things, metals. In Delaware, where I also work, we have a lot of iron in the water. So heavy metals are an issue. And of course, pesticides, hydrocarbons, petroleum-based compounds, and so forth. But where a contaminant comes from very often dictates how it has to be treated, and how it got there in a lot of cases. Surface water contamination is typically nitrates or bacteria. Some things are found in the groundwater naturally, as I said, which can include nitrates because it does leach down. TDS or total dissolved solids, if your water is cloudy and may have a lot of solids in it. Fluoride also occurs naturally in groundwater, which is also a surprise to folks sometimes. And of course, iron and hardness can be a problem. The big one that can cause you problems in other ways is the pH, the corrosivity of the water, because that can cause some of these other things to leach out into your house. Again, copper, lead, typically don't come from the water itself. They come from the plumbing because the water is too corrosive. Let's look at this to be not very sanitary, and looks to be a dump. So there's a leachate plume here that's pointing towards this home and this well. They're kind of in the same strata. I just got a message that my internet connection is unstable. If you're having a problem hearing me, please put something in the chat box. Or seeing me, for that matter.
Jean, you're cutting out. You were cutting out a bit just now. It seems like it's back to normal, but we can let you know if it gets bad.
Okay. Well, I do live in the country, and my only internet connection is through a jetpack. I can't get wireless or anything out here, so that explains part of it. But you have this plume that is migrating through the groundwater, because as you can see, it's sloped downward. And the well for this home is downstream of this unsanitary landfill. And as they pump that well, it's going to pull that plume eventually right up and into that house. So that's how whatever's on the surface can affect what you're getting in your house, really no matter how deep your well is. Generally, you tend to think deeper it is, the safer it is, because of all this dirt, all of this earth that filters whatever's on the surface. But that can be problematic too, for example, where our office is, the more iron you get. So it isn't necessarily so that deeper is better. It depends on what you're talking about. And here's another cross section to help you see the difference between this, what one difference in the same scenario. So here we have a home and a septic tank, and the grade is going downhill, and the septic tank groundwater movement is going to the left in picture A. And this small well is pumping nice clean water. Well, here we have the same situation in picture B, and upstream of that is an irrigation well that is pumping. It's deeper than the household well, and it's pumping much more heavily at a higher rate, at probably a higher diameter well casing, etc. And it's going to suck that pollution, that septic tank leachate, right into this household well, and it will be contaminated by bacteria. Even though it may not actually reach this heavily pumped well, it's going to contaminate that household. So same scenario, but one variable changes the whole picture. Everything depends on the hydrology of the soil as much as it does the depth of your well. So here's another one of those questions that you probably should know or try to find out, and that is, how deep is your well? Are there different stratas that are near you? Your neighbor could be in a different strata than you are and have different depths of well and different quality water. So don't go by, well, my neighbor's water's fine, mine should be fine. That isn't necessarily so. Lead, again, lead is a big thing in the news, and it is very dangerous for children under 6 and pregnant women.
Hey, Jean.
But potentially dangerous. Yes.
So sorry to interrupt
Yeah,
you.
somebody's talking.
Yeah,
That's
that's
all
me.
right.
That's me, Daria. I was just going to suggest maybe it's worth turning your video off. Sometimes that helps with the bandwidth and helps with connection issues. So you could try turning your video off.
Okay.
Yeah. Okay.
All right. There we go. Okay. There is no safe level of lead for anybody. No lead is safe. But it is particularly harmful to young children and pregnant women. Lower pH, the more corrosive the water is, the more likely you are to have higher lead levels. If your house is older, in particular, built before 1984, chances are if the water pH is lower, that could cause problems because of the composition of the pipes. And this was something that I found very surprising. And I've been doing this for a long time, but until 2014, you could call plumbing material lead free and it could still contain up to 8% lead. I think that's a little scary. If it's very corrosive, that could mean that much more is leaching out and you think you're safe because you have quote unquote lead free plumbing. This was a study that was done by a postdoctoral fellow at Virginia Tech. And they found that in the 2-year period between 2012 and 2014, 19% of the 2,000 and some private water wells that were sampled in Virginia exceeded the action level. But they also observed, and this is important in view of the previous slide too, that lead-free plumbing released lead when it was exposed to more corrosive groundwater. And that's important to us in Maryland and Delaware because on this USGS map of corrosivity of water, the dark orange is the highest prevalence of corrosivity, and there we are, Maryland. Very high prevalence of corrosive water. I don't know the figure for Maryland, but I know in Delaware the average pH is 5.5, which is on the acid side. Neutral is 7. And I'm no chemist, but the difference between 5.5 and 7 is more than just a 1.5. It's like a logarithmic difference for each point of pH. So possibly if you have a lead problem, not only do you have to have certain treatment like reverse osmosis, whatever is recommended, but it might also raise the pH to keep that lead from leaching out because of the corrosivity of the water. Excuse me. Protecting your well, obviously you need to protect it from being hit by cars. We know in our family from bitter experience, you also need to protect it from being hit by lawnmowers. My daughter's well has been hit 3 times by a lawnmower and broken off. The casing was broken off below ground level in one point. And instead of having it to buy a licensed professional, if your well is ever hit and you think there is any kind of a crack in that casing, whether it's visible or not, you should have a licensed professional well driller look at it. Because in my daughter's case, someone fixed the person who hit it, fixed it with materials just from Lowe's or whatever. And she was pumping grass clippings out of her wells for several weeks after that. So don't try to fix it yourself if you do hit it. Don't store or apply chemicals within 50 feet of your well, a 50-foot radius. That I can't overemphasize because whatever, especially if it slopes down towards your well casing, whatever you pour out on the ground could migrate and run down the side of that well casing and get in the aquifer, and you will eventually be drinking it. Of course, don't locate your well in areas where animals or livestock are kept. I have personally seen a well that was in a cow pasture. I was horrified. It was pretty old, but still. And you should not try to chlorinate your well yourself either. You should have a professional well driller do it, and they will determine whether it needs to be chlorinated. Going back to my daughter's example, after it was hit the 3rd time, they had a professional well driller at my insistence come and look at it to make sure. First, they did a sounding to make sure that the case was not cracked down near the pump or anywhere in the drop pipe. and then super chlorinated it to 50 parts per million for 24 hours. And then you flush it. But don't try to do it yourself, because Clorox is half the strength of commercial well chlorine. So if you can you'd have to put Clorox, in other words, into the well to get to that 50 parts per million as what a professional well driller could do. You should always do an annual visual assessment of your wellhead, that pipe sticking up out of the ground. You can kind of tap on it, and you can sometimes tell if there's a crack. You can feel a vibration, much the way if you were ever in school and played ball, as I did, with a wooden softball bat. If you tap the handle of the bat on the ground, it was cracked. Sometimes you can feel that in the well pipe as well. Should make sure that the seal is airtight, that there's not a bunch of spider webs or a wasp's nest in there. If you do have a big enough well to have a two-piece vented cap, make sure that's tight, and that a lot of times there will be nests built in the gap between. This people don't think of as affecting the groundwater sometimes, but make sure you inspect your septic system on a regular basis and pump it out on a regular basis. I know particularly our septic hauler, we're set up on a regular file. They send me a postcard and say it's time to pump your septic. Otherwise, I'd probably forget. The standard wisdom, depending on how many people are in the house, is less than every 5 years. I have mine pumped every 3, and there's only 2 of us in the house now that the kids are grown. But your septic hauler can probably recommend what the best interval is for your system. But if you've never had it pumped since you lived there, it's time to think about it. And if you're living in an area with a lot of small lots, encourage your neighbors to do this as well, as much as you can without making somebody mad. But it's something that protects everybody's groundwater, not just yours. Information you should have: you should know how deep your well is, within a foot or 2. The age of well and pump. I know we've had to replace our pump once since we've lived here since 95. So I know how old my well pump is. I don't know how old the one it replaced was, because that was put in by the previous owners. What type of well you have, the diameter of it, and where the pump is. If you're told that your well is drying up, it's possible, depending, it only works maybe once, maybe twice, is that they can lower the screen and lower the pump rather than putting in a new well. It's possible, but know where that pump depth is and what the pump nameplate rating is, how many gallons per minute. There are certain minimum requirements. Maryland will give you a certificate of potability after your well has been installed. That goes back to the regulations. You're not regulated except when the well is installed, when it's drilled. And they give you a certificate of potability before you're allowed to use it. But after that, you're on your own. Every situation is different. It depends on the depth of the well, how often you should test, the geological formation or the strata of the aquifer you're in. Again, you and your neighbor could be in the same aquifer, but you're in a different strata. You could have completely different water quality. Probably not that usual, it's possible. Whatever the known contaminants are in the area, and of course we already know that nitrates are prevalent in and around us. I have a community neighboring town spray irrigation site across the road from my house. The geology of the area means that it tends to run away from my house towards the river, but still knowing what that kind of what's in your area and what the possibilities are, the potential is. I suggest asking your county or state health department for what you should test for, or even a lab if you deal with a private lab. Sometimes cooperative extension may be able to help. Anything that's been identified in your area and has grown to be a problem, but certainly nitrates. And I know it's not necessarily required, but when we moved here, our lender required us to have the well tested, and we had to do it on our own dime. And if thinking about a house, it might be a good idea to do it whether you're required to or not, just so you don't get surprised and back bit later. Some suggestions: every year test for coliform bacteria and nitrates, particularly if you live in an agricultural area or one of those developments where everybody's grass looks like green velvet. They're putting a lot of fertilizer on it, chances are. You live near a golf course. I happen to be married to a farmer, so farmer is not the only culprit in contributing nitrates, but that's my personal bias. But certainly check for bacteria, because you could not have bacteria one week and something be done upstream of you that you don't even know about, and the next month you could have bacteria. So you need to have that checked at least annually. And when you first move in, and then every 3 to 5 years thereafter, it's suggested to test for fluoride, which again occurs naturally. And you don't want it to be above 4 parts per million. That's the national standard. I know that one community I worked for about 5 miles up the road from me, their natural occurrence was 2 parts per million, so they didn't even add any. But again, it does occur naturally, and if it gets above 4 parts per million, you could get fluoridosis, your teeth could turn dark, a lot of problems with that. Iron can be a big problem in the groundwater. Lead, yes, I agree that it should be tested for lead, but you really need to pay attention to the pH, because the pH is going to exacerbate any kind of lead problem, or even an iron problem for that matter. Manganese can sometimes fool you into thinking that it's iron, because sometimes it shows up as the same color in the toilet, but it also tends to turn black if it's very high. But in the beginning, it can be rusty brown and you think you have a lot of iron. So every 3 to 5 years, have your well tested, your water tested. If you have copper piping, test for hardness and copper every 3 to 5 years. Again, copper can be dangerous to people's health too. It's not quite as dangerous as lead, but the lead and copper rule for community systems is in place for a reason, because copper can cause you a lot of health problems. If you have galvanized piping, you should definitely test for zinc and cadmium periodically, because those can be very toxic. Arsenic, again, arsenic is a scary word. That's like saying I have cyanide in my water, but arsenic does occur naturally in the ground and in the soil. Turbidity or cloudiness, and total dissolved solids. Turbidity can be problematic, and I have had at least one member of my family talked into buying a filter system because the water was turbid, cloudy. And my comment was, well, if you pour a glass of water, does it clear from the bottom up, or does it clear from the top down? If it clears from the bottom up, it's air. It's air bubbles, tiny little air bubbles. If it clears from the top down, then you've got solids. Then you've got real particles of some kind. And the alkalinity, which is, related to the pH as well. Main thing is to get advice beyond this. These are suggestions, but to get advice beyond this from your local or state health department and what they find in the water. Or if you're already going to a lab once a year or every 3 to 5 years, then they'll tell you what they suggest you check for. There is a new law in Maryland, pleased to say. I would like to see that happen in Delaware, but there's a new law in Maryland that landlords are required to test private wells every 3 years. And if a contamination is found, they must provide the tenant with an alternate source of drinking water. And they must address the contamination within 60 days of finding out about it. I'm sure landlords don't like it, but I personally think that's a wonderful law. And it's effective October 1st, 2021 in Maryland. So coming soon to a theater near you. If you are a tenant, make sure your landlord is aware of that. If you're a landlord, you need to be aware of it, because it is your responsibility and not the tenant's. How to test? Well, in Maryland, you pretty much have to go to a private lab unless the health department will come run a test for you. And it depends on what county you're in, whether they do that or not. And the reason I say it has to be a private lab, we do have a program in Delaware where for $4, you can get 2 test bottles, one for chemicals and one for bacteria, along with instructions on the sample, take it back to the environmental health division in each county, and they'll take it to the state lab and test it. The same array of tests probably runs, I'm sure, more than $100 in Maryland, $100, $150. There's a number of private labs. If you're in Worcester, Wycomico, and Somerset, there's Maryland Environmental Labs, was formerly known as Chesapeake Labs in Salisbury. There's EnviroCorps. I know they have an office in Harrington, Delaware. I'm not sure where else it might be on the shore, but that would be two suggestions. But certainly you could do a Google search and find out where there would be private labs. And I know my time's getting short. I'm trying to wrap it up here. Cooperative extension, depending on the county, they can help you as well. Cost and the capability that they have of what they can test for depends on, where you go. And they'll each have their own procedures, and they'll provide you with the sample bottles. You don't want to walk in there with a mayonnaise jar full of water and ask them to test it for bacteria, for one thing. Just very quickly, I was talking about total coliform bacteria. This is a sample from, oops, sorry, I'm distracted. I can't see the top of my own slide, but total coliform, if you can see, the sample was, I believe, 5,600 and some systems. 41% were positive for total coliform. But if you look up here at E. coli bacteria, only 9% were positive for E. coli. So that illustrates what I was talking about, the difference between total being an indicator. Total means let's test for other things, but there's a big difference between total and E. coli, the ones that'll really hurt you. So that's just a representation of how often things are found, how many are above safe drinking water regulations, even though that doesn't apply to private wells. This was a study done by a couple of nursing students, master's students. Why don't people test for the water? And this was Wisconsin, Minnesota, and Michigan. Why don't you test for your water? Well, 53% people said we've been drinking it for years, and I hear that every day. That water's fine, tastes fine. And 52% are not the least bit worried. And then they asked, what would you do? What would be enough of incentive for you to test your well? And some people said, well, $2 plus a free test, or a coupon for a free test, or whatever. Of course, everybody wants it free, but the statistic, the one that slayed me, was number 10. I don't want to know. I asked a man one time, an older man, I said, if you haven't had your well tested, how do you know it's safe? He said, I ain't dead. That's a heck of a way to find out, if you ask me. But at any rate, that's kind of a standard answer. Well safety, very quickly, if you have any unused wells at all on your property, make sure that you have in Maryland, you are required to have a licensed well driller properly cap those wells. But if you have a hand dug or a bored well, they can be particularly dangerous. Number one, they punch a hole in that aquifer. They're allowing an opening for something bad to get in there. But they're also very physically dangerous. And I'll just show you a couple of quick ones. Most people remember baby Jessica from years ago. I think she's in her 20s now, if not 30, but she fell down a well and stayed for like 2 days before they got her out. That's a horse, a grown horse fell into a well. People have been killed by falling into these abandoned, hand dug, or bored wells. Here's why you need a pitless adapter. The upper left, that's a well pit. And somebody just put a piece of plywood over it, and the plywood rotted, and a woman fell down in the well and died. Here's another one. That's some pretty crummy looking water I don't particularly want to be drinking. So these are examples of wells that really need to be capped professionally. And there may be more wells on more undocumented wells than we're aware of, because well logs weren't really required until the period between the 60s and the 80s, depending on the state and the county that you're in. Like well pits, they're really a safety hazard and can be extremely dangerous. So in Maryland, you are required to have it capped by a professional. You can't do it yourself. But you would be responsible if somebody fell down and got hurt, or if you contaminated the aquifer for other people. So it's an important part. Again, be mindful that groundwater is a limited resource. There are many areas, fortunately our area is not one of them at present, but there's a lot of areas where recharging the groundwater is not keeping up with the amount of pumping. And as irrigation systems become more affordable and therefore more prevalent, that you're going to see more of that all the time. It bears reminding that less than 3% of the water in the world is not salt, is drinkable, is potable, but a large percent of that is frozen or underground. So only about 1% of the water in the world is actually available for drinking and bathing and so forth. So it may be a renewable resource, but if we don't renew it as quickly as we're using it, we're going to be out. Again, the groundwater cycle, there is no new water. Some other resources, I'll run through these quickly because if you get a copy of the slides, you'll have access to all of this without me having to explain it. We do, of course, the health department, but CERCAP does individual well assessments. And we do those in association with the private well class and the National Groundwater Association. Our CERCAP loan program is very attractive, particularly for Marylanders. It's a 1% loan for as much as 10 years. I'm going to go into this in a little bit about why it's attractive for Marylanders. The private well class is something it's based at the University of Illinois, and they have a lot of things, and I'm going to go into these pretty individually here in a second. And online interpretation tools of how to read your well test and what it means and so forth. National Science Foundation. So first, CERCAP and our loans. We are a USDA private well loan administrator. It's available for replacement wells or repairs to existing wells. It is not for new construction. Low to moderate income homeowners, and in Maryland, the income limit is $106,000, much higher than it is for some of our other states. So a lot of folks would probably qualify. Can borrow up to $11,000 at 1% interest, and it's 5 to 10-year terms depending on your income level. One caveat is you have to reside in an area that's eligible for USDA funds, of course. There's a link, and again, you'll see that again in the resources, and but that'll take you to our web page and our services and tell you all about the program and how to apply. The private well class, again, has a series of 10 lessons that are done via email. It's self-paced, it's voluntary, it doesn't cost money. They also have webinars, 6 different ones, or they have one every month, giving people a chance, they're interactive, to ask questions. There's a link to their website. They have multimedia lessons. You can ask questions. It's a very, very good resource if you want to learn. If you get your well test back and you don't know what it means, here's a website, a link to a website for Penn State University, extension. And you put in whatever the number was on your well test. You got a positive for total coliform, or you got a positive for benzene. You put in the milligrams per liter, and it'll tell you what it means. It helps you interpret whatever those results are. Then we have the NSF, National Science Foundation. There's a link to their page, which will tell you if someone tries to sell you a water treatment system, you can put in what you're trying to get out of your water. Let's say you have an iron problem. You can put in iron, and it will tell you which devices and systems are approved for reducing iron or lead or whatever the case may be. To me, this is a very valuable tool, and it keeps people from buying systems that they don't need. Because if someone is offering you a free water test and trying to sell you a system, I guarantee you they're going to find something wrong with your water. And that's a way to find out. We have a number of different resources on how a water well is drilled, the National Drilling Association, the National Groundwater Association, another really good resource, Groundwater Awareness Week, and so forth. And again, I'm rushing through these in the interest of time, but you'll get them when you get a copy of the slides. Some other links, again, National Groundwater Association, U.S. Geological Survey. The Maryland link to well permits and water management permits is listed. And then here's our contact info. This is our present staff. Vicki Prettyman is the state manager, and I'm a TAP, and Jewel Gibbons is a TAP, and I believe she's on the call or on the Zoom meeting. And Daniel Wilson is also a TAP. And then questions. Be happy to entertain verbal or written questions.
Thank you, Jean, for this great presentation. I even learned a ton just watching this. As Jean mentioned, if you have questions, throw them in the chat. We got one during the presentation that asked if we would get a copy of Jean's slides. Yes, we will send them to you all. And I've been putting some of the resources that she's mentioned in the chat as she's been going through. But yes, you will get those slides. And we're recording the webinar so you can watch it again as many times as you'd like. So with that, if you've got questions, throw them in the chat and we will make sure to share them with Jean. All right, Jean, we've got one from Jay Gibbons. In Maryland, would it be recommended that homeowners use test strips as a low-cost alternative to lab testing in the absence of subsidized government programs?
That would be a good indicator that maybe more testing is needed. I'm a little skeptical as a water professional. I'm a little skeptical of test strips because you need to know how old they are. They will fade in the sun and things like that. But just as the study used a nitrate and nitrate test strips, it's a good indicator that if that thing turns, bright purple, then you need to go further and have a lab test. So yeah, in the absence of subsidy for testing, the way we have in Delaware, that would be a good alternative. I wouldn't use swimming pool test strips, not a good idea, but yeah, that's a good question. Thank you, Jewel.
And I want to add to that too. So we can certainly send the link to the test strip that we used for the Lower Shore Safe Well Water Initiative and the follow-up. If folks are interested, we can share that. But something to note to Jean's point about the accuracy, what we found with the Lower Shore Initiative is that when we did do testing and then someone had a strip result that was 5 milligrams per liter above and then got the confirmation lab test, for most of the cases the lab test actually yielded higher nitrate results than the strip tested. 1 or 2 times it was less, but most of the time it was more. And so it was sort of in the right ballpark, but in some cases brought that person over the hump to over 10 milligrams per liter. So yeah, we would recommend lab testing.
Yeah, I would think that would be pretty typical. And again, if you use the strip, don't rely on that solely to determine the amount of anything in your water. Use it as an indicator that you're probably okay or you need to go farther.
Mm-hmm. So Gail asked, can you give the PSU website to interpret the lab results again? We can pull that up on our end and put that in the chat for you, Gail. Because I did try the link and I was having some issues with it. So I'll try to put an updated link in the chat. And then we have another question from Joe Fields. If a well log can't be found, what should I do?
Well, I would normally ask our regional private well tap, whose name is Joe Fields. I've had some problems with, and I'm not trying to be facetious, it's the same Joe Fields. A lot of times if there's a tag, a metal tag around your well, it will give you a driller's number and name, or at least a name. It will also give you a permit number, and you can sometimes contact your county and find out information about your well from that permit number. Sometimes. I have tried that in Wycomico for my daughter's well and just basically didn't get called back. And if there's anybody on here from Wycomico County, I apologize, but it's the truth. if you can't find a well log, I would rely on your advice, Joe, to tell me what to do next, because that you'd be my first call. And I don't mean to pass the buck either.
Yeah, I mean, it's great to have CERCAP's resources, and I would agree with that. Reach out to your county if you're having trouble reaching someone. And Joe,
Or call us, and I'll give you Joe Field's number.
and he says you can use the well tag or log that is closest to home, so that's a good alternative too. It's helpful to know that at least when we were doing our research at CPR, we actually found that counties also maintain well records in very different ways. So Worcester County, for example, has a great a spreadsheet database that has all the well permit numbers, the information from when it was tested. That was very easy to access. But you know, Wycomico and Somerset have paper records that are stored somewhere. They have to individually scan them. So it can be a little bit, it depends on your county, but they should have them available from when it was built.
And if you bought your house from a really conscientious homeowner, they've kept all the records for you. I know one of my daughter's friends had a whole loose leaf notebook, and she knew everything about, she had copies of the original permit and everything because the previous owners had been so good about it. But you may not be that fortunate. You just go with what you have and start digging as best you can.
Yes. So I found and updated another link for the PSU. I found their water quality laboratory. So we can double check later, Jean and Gail. I'll resend that to you later.
If there's a mistake in the link, it's entirely mine, believe me.
No worries. Joe also added, also the age of the home will affect certain well data for that stuff.
Right.
So we have time for maybe one more question. If anyone has one, now's your chance to pose it in the chat. But otherwise, we've got our email addresses in the chat box. So feel free to reach out afterward if you'd like. And again, we'll send all these resources as well as the slides and the recording to this webinar to everyone after.
And please feel free to call us. Seriously, we can help you. If you get your well tested and you don't understand the report, we'll help you too.
Wonderful. Thank you, Joe. All right. Well, if there's no additional questions, thank you everyone for joining today. I hope this was helpful and interesting. And you know, the whole goal of this initiative and CERCAP's work is to help folks have the tools and information they need to safeguard their drinking water and their, you know, their family and their own health. So let us know if you have any additional questions, and we'll follow up with all the information after. With that, I will release everyone. I hope you have a wonderful rest of your evening.